This is where we left off in the last video. I threw up the last slide from the last video. We can start here. Quick review on this code. This is flowchart programming with a Velocio ACE 11. And if you look at the start, it drops down to start sealed in on. Well, it's red, it's not on. You see the N and the Y coming out of the decision block. No, it goes down, it resets the complete sequence timer. You know it's a timer. And all the instructions that have that little alarm clock on them, these involve the timer. It resets the timer, then it goes to the next decision block, which is also red, is input bit C1. Now, input bit C1, that happens to be the start push button. If it's not on, then it comes out the N corner, no, goes up to the top, and it just cycles through these three blocks 1,000 times or more a second. Comes the day or the time or the moment when that block is turned on, then it's going to say yes, go out the bottom to start sealed in. It goes up to the top. That's now on. It's going to go out yes. It's going to start the timer and move over into the actual sequence. There was several things that I didn't like about this. The one, which is not that important, but this timer is not like a timer data type in a PLC where you have an enable, a timer timing, and a done bit. Now you can simulate those things. You can kind of accomplish the same thing. But this kind of timer, once you start, it just keeps on rolling. Even when the sequence is done, it's still running until you reset it. If you had 2 or 3 days between when you ran this little train system, I don't know if it would run out of, the highest value with 32 bits, a double integer, or not. But I'm not going to let it do that. I'm going to force it to stop after each sequence of the train. And then the other is that I don't want them holding the button down. I want them to release it. I'm going to add code. They push a button that initiates something, but it won't run the sequence until they release it. Here's what we've added. For the prevention of holding the button down, you see you come in, and once you've got start sealed in because you push the start push button, now that's true, then it comes over and it says, is C1 start push button off? If it's no, because you haven't let go of it yet, then it resets the timer and goes back around to the beginning again. And if you have released it, then it starts the timer. The other thing I added was a little delay here for a particular behavior that I didn't care for. This eliminates it. Don't worry about what it does, but it does give a 1 second delay. Here's what it looks like when it's at rest. Red decision blocks means they're false, if you like the word false, versus true. And because remember that the first two say on. If it's on, they would be green and go out the yes corner. If they're off, they would say no and go out the bottom. But you see that right now our start push button is off, and that's why that decision block is green, the second one on top. And most of the rest of this we've been through before. Until you start the timer and have a true signal sent that way, then the sequence timer is going to be less than 181 seconds. 181 seconds is the full length of the sequence. And you look down at the bottom, the red one, greater than or equal to 180. The sequence runs up to 180, then resets. Okay, if we press the button, the start button, green lit push button, we'll eventually add an output to turn that light on during the time that the timer is timing and you're executing the sequence. But right now, you push the button down, and remember that first decision block, start sealed in, that was false. It came down through no reset, and the start push button was pressed. That was green. It cycles back up to the top, and now that one's true and is going out the yes. But you won't see that happen. You'll go right from both of them being red to both of them being green because it all happens at 1,000th of a second. Right now, the start sealed in bit is on, but you're still holding on to the start push button. Once you release that start push button, then The first one, and of course, notice that when you went between the two, notice that the two that address C1 start push button, one's red, one's green, now they flip. Now the start sealed in is on. You've sealed in the start and you've released the push button. Now it starts the timer and it starts going down through the time sequence. And of course, right away, it's not greater than 1 second, not greater than or equal to 1 second, so that's still red. But very quickly, that will turn green in less than a second and start executing the rest of these, if you want to call them timer states. And I skipped one here. I went, less than 7. It turned on the at station voltage to the locomotive. And now it's doing the less than 15. The first red one, less than 7. That stayed on for about 6 seconds. And then it's still less than 7 as long as it's red. But remember that these decision blocks are going to reflect the state. It's just going to step right down through them until it gets to the end. And this part is the same it was before. All we did was we added the had to release the button up at the top over to the left, and then we added that delay. And that's all there is to the sequence. If we step back down through it, now that we're over 1 second, then now we're less than 7 seconds. You notice I'm looking at the numbers now, not the name. Okay, when it gets down to the end, that last decision block down there will turn green in a technical sense. In other words, it will go true, yes, and then it turns off the at station sounds and it turns off the start sealed in bit. But you'll never see it go green. It goes yes, and then a second less than a thousandth of a second later, it's no. You'll never see it turn green. That's the sequence.